Hello children, dear students, in today's lecture we are going to study first point, that is amphoteric nature of what? Water. Amphoteric. Children, what is the meaning of amphoteric? क्या मतलब होगा amphoteric का बोलो? Amphoteric means it is associated with the amphibians, having dual property. Likewise, in chemistry, when we say that a particular compound is amphoteric in nature, it means that we say that it may react as an acid as well. It may react as a base. So, if any substance having both the properties, that is, it is acid as well it is base, then it is known as what? Amphoteric. Regarding water, we can say that water is amphoteric in nature. To show that water is a acid as well as it is a base, it means that it is having amphoteric property. We will take the help of the two reactions. First reaction, where we allow water to react with ammonia. We know that ammonia is a base. So, moment it reacts with the base, it produces ammonium hydroxide. The important thing is that water is donating a proton to ammonia. Means it is acting as an acid. Ammonia is accepting the proton, so it is base, and now the product which is getting formed. So reaction clearly tells you that ammonia is base, so water is definitely a acid. Now children, we will move for the second reaction, where water is reacting with the HCl. Now children, we all know that HCl is the acid. So it is the acid. Now in this reaction what happens? Water will accept the proton. This hydrogen will split over here, come out as H plus ion, leaving behind a chloride ion, and this H plus ion will combine with the water, and now it will become H3O plus and chloride ion. In this reaction what has happened? In this reaction HCl has donated a proton and water has accepted that proton. Children, in my previous lecture I have discussed with you Lorry-Bronsted concept, and according to the Lorry-Bronsted concept, acid is a substance which can donate a proton and base is a substance which can accept a proton. So here, since water is accepting the proton, thereby it becomes H3O, hence it proves that water is having a property of behaving as a base. So children, here we are having proof which tells you that water can behave as an acid as well as a base. Hence water is what? Amphoteric in nature. So now children, let's move for the second point, that is, now we are taking the concept of ionization of acids. Ionization means what? Splitting of a substance into what? Ions. If for example I am taking acid, HCl, it will split into ions H plus ion and chloride ion. Similarly, we can take acids like acetic acid, that will also split into ions CH3, COO. First we will write the H plus ion and then we will write acetate ion. But difference between these two reactions is the one that this reaction is reversible. Means this is the strong electrolyte and this is going to be the weak electrolytes. Childrens, like this we have got bases which are strong as well as weak bases. As long as we are discussing the strong electrolytes, reaction gets completed, means we are taking HCl, entire HCl will split into ions. End of the reaction, you will not be having any of the associated molecule. All what you are going to have will be the ions. But in case of the weak electrolyte, what happens? The substance acetic acid will split into ions. Again ions will combine and come back into the acetic acid form. Means we are going to have some acids in the associated form, some acetic acids will be in the associated form, and some acetic acids will be in the dissociated form. Initially, suppose I am having 1000 molecules. For example, particular number of molecules, say 990, will remain in associated and 10 molecules will exist in the dissociated form, in the splitted form, in the form of ions. So children, for such weak electrolytes, by applying law of mass action, we obtain a derivation. Let us see what is the derivation. That derivation tells you, at the stage of equilibrium, we all know what is equilibrium. Reaction is moving forward, again reaction is coming backward, and in course of time you find that there is no change in the amount. Now values are constant. Apparently it appears that reaction has got stopped. Reaction is not going on. But in reality, reaction is already going on. Reaction is still going on. Only what not changing is the concentration. Concentration of the reactant as well as concentration of the product. And since concentrations neither side is changing, so we say that now equilibrium has been established. So we use a word at the stage of equilibrium. At the stage of equilibrium, when rate of forward reaction and rate of backward reactions becomes equal, apparently it looks that reaction is not occurring. But in reality, reaction is going on with the equal speed in both the directions. So that stage is known as the stage of equilibrium. Once you start the reaction, after some time, that stage will be achieved. And now we are working at the stage of equilibrium. At this stage of equilibrium, concentrations are not changing. So I will be taking ratio of each concentrations. Concentration of the products divided by the concentration of reactant, and this ratio is known as the dissociation constant. Dissociation constant. So children, this equilibrium constant is known as the dissociation constant of the acid. Dissociation constant of acid is nothing, simply a ratio. Ratio of what? Ratio of the concentrations. Concentration of the reactant, concentration of the products at the stage of equilibrium. Not any other concentrations. When you are starting the reaction, concentrations are changing. Once the equilibrium has been established, now every concentration is fixed. This fixed number I am keeping here. This fixed number I am keeping here. And the ratio is known as the dissociation constant. Now, after looking at the mathematical expression, let's see what is the meaning of this ratio. Children, this ratio tells you at equilibrium, for every 1 mole of undissociated molecule, how many ions we are going to have. And thereby, we can decide how much stronger is the acid. So this has become a tool to decide the strength of the acid. Now we can move similarly for the bases. We can take a general example as I have taken for the acid. We may take a general example for base. If suppose BOH, and children writing this side, BOH is a acid, is a base, and here I am taking HA as a acid. Acid, if it dissociates, it will form H plus ion and A minus ion. These are the symbolic representations. So Ka value will become H plus ion, A minus ion divided by concentration of undissociated acid molecule. On the same line, we can now write for the bases B plus and OH minus. Again, for base I am using Kb, B plus OH minus divided by BOH. This is known as the Kb. Dissociation constant of the base. Dissociation constant of base. Also equilibrium constant. Law. Children, Arrhenius has given definition of the acid, and the same concept was extended by Ostwald. What contribution he has made? He has made that concept quantitative, means he has developed a tool by which we can even measure the strength of the acid. So let's see about it. If suppose the acid HA is there, and if it is a weak electrolyte, it will split into the ions and equilibrium will be established. HA is splitting, H plus and A minus ion. They are again combining and coming back to the HA. So association and the dissociation. Associated form, dissociated form. And equilibrium has been established. Initially, before the equilibrium, suppose you are having 1 mole of HA. Suppose 1 mole of HA we have taken. initial, I am writing here initial stage. Initially. Then we are not going to have any of the H plus ion and A minus ion. As the reaction progresses, slowly H plus ion, A minus ion all will start forming. Their number will start increasing. And then comes a stage of equilibrium. Number has now reached to the stage from where we are not finding any change. I will show it with a diagram. HA is there. This is the initial stage. Then slowly H plus and A minus ions will start coming. And then there comes a equilibrium, stage of equilibrium. At this stage of equilibrium, though the reaction is going on, reaction has not been stopped. Reaction is still going on. But the thing which has stopped is the change in the number. Number of H plus ion and A minus ion is now fixed. Number of HA ion is now fixed. This is the stage of equilibrium. At this stage of equilibrium, now we write at the stage of equilibrium. If suppose alpha is the degree of dissociation, at this temperature, this much part will dissociate. Degree of dissociation, I am using the word degree of dissociation, alpha. Degree of dissociation tells you number of moles dissociated to the total number of moles. This ratio tells you every 1 mole what part will dissociate. Half mole, 1/4 mole, what will dissociate? That is known as the degree of dissociation. This we can understand with a very simple example. Father has given 100 rupees to his 2 children, 100 and 100, and ask them to go and do the expenses or whatever they want. Mr. A, he returned back with 50 rupees. A has returned with 75 rupees. Where is the more expenses? Who has done the more expenses? This Mr. A. 50 rupees, he has done the expenses of 50 rupees. He has done the expenses of 25 rupees. If next day daddy is giving 1000, definitely he will come back with the 500, whereas he will come back with the 750. If daddy is giving only 1 rupee, then he will come back with the 50 paisa and he will come back with the 0.75 paisa. So like this, father has judged which child he is doing more expenses. This is what we are doing here. Degree of dissociation tells the ability of the given acid to get dissociated. Someone is having more tendency to get dissociated. Someone is having lesser tendency to get dissociated. It depends on the nature, on the chemical constitution of the substance. So here, alpha is the degree of dissociation. And for the substance in the hand, if suppose we consider that alpha is the degree of dissociation, then 1 minus alpha will remain. If suppose 25 paisa he has done the expenses of 25 rupees, then 75 will remain. Likewise, out of 1, alpha is the degree of dissociation, so this much will go away. How much will remain? 1 minus alpha. If suppose alpha molecules are turning into the ions, we know that every 1 HA, when dissociates, it forms 1 H plus ion and 1 A minus ion. Am I right? Whenever one molecule dissociates, it produces 1 H plus ion and 1 A minus ion. On the same line, if alpha molecules are dissociating, then alpha H plus and alpha A minus will be produced. Now concentration is always expressed by number of molecules divided by volume. Number of molecules divided by volume. Now children, if I have to write here HA, I will write this way. Ka is hydrogen ion concentration, A minus ion concentration divided by HA. In case now we will be putting their values. So Ka is going to be alpha upon V. Again alpha upon V, 1 minus alpha upon V. Simply I am putting their concentration values. Ka is now going to be alpha into alpha will become alpha square upon V square, 1 minus alpha upon V. Ka I will write as alpha square upon V square into V upon 1 minus alpha. This will get cancelled. So Ka becomes alpha square 1 minus alpha dot V. This V I am writing. Now children, 1 minus alpha is approximately equals to 1. Because alpha is very small value. Because alpha is very small value. So 1 minus alpha is as good as 1. If it is 1, then Ka value is going to be alpha square 1 into V is V. Now children, 1 upon V means what? Concentration. 1 upon V is nothing but concentration. So Ka becomes alpha square dot C. Also I can say that alpha square equals to Ka upon C. Further, Ka was alpha square upon V. So you can say that alpha square equals to Ka dot V. Alpha is, now we are going to see Ostwald's dilution law for the bases. If suppose I am taking an example of the base like BOH, it will split to form B plus ion and OH minus ion. Now initially we are going to have 1 mole of base, ions will not be present at all. Now at equilibrium, if suppose alpha is the degree of dissociation, 1 minus alpha will remain in the undissociated form. Alpha B plus and alpha hydroxide ions will be formed. Now we can write concentration at equilibrium will be 1 minus alpha upon volume and again alpha upon volume. By law of mass action, at the stage of equilibrium, we can write Kb equals to concentration of B plus and concentration of hydroxide divided by BOH. Kb is going to be alpha upon V, 1 minus alpha upon V. Now children, Kb is going to be alpha square upon V square, 1 minus alpha upon V, this we can cancel. Kb is going to be alpha square upon V into 1 minus alpha. One minus alpha is approximately equals to 1. So Kb is going to be alpha square upon V. We can say that alpha square equals to Kb dot V. Alpha is under root Kb dot V. Also we can say that Kb equals to alpha square dot C, because 1 upon V is nothing but concentration. So Kb equals to, here I can say alpha equals to under root Kb upon C. So children, here you have seen this derivation is word by word same whatever we have done for the acids. So in the exam, if they are asking you for the base, you have to start with the BOH, and if they are asking you for the acid, you have to start with the HA. They may ask you, obtain the Ostwald's dilution law with the, explain Ostwald dilution law with the help of base or with the help of acid. So as per the question, you have to answer, and the things are derivations are dicto same. Only in case of acid you have to write Ka, and in case of the base you have to write Kp. So children, now we will move for the fourth point of the lecture, that is auto-ionization of friends. Now we are going to study auto-ionization of water. Dear children, do you know even water ionizes? Means water molecule also splits in the form of ions. Just like HCl. HCl splits into ions. Even water splits into ions. But only difference between HCl and water is the extent to which they dissociate. Up to what extent? HCl 100% dissociates, but that degree of dissociation of water is very low. At room temperature, it dissociates to the level of 10 to the power minus 7. What is the meaning of 10 to the power minus 7? Means 1, 2, 3, 4, 5, 6, 7. Out of 1 crore water molecules, only 1 will dissociate. Out of 1 crore, only 1 will dissociate. So this value is extremely small, extremely low. That is the why we are able to drink the water. Had the degree of dissociation been larger, then this would have become impossible to drink, and thereby existence of life even would have got extinct. So dear children, water is having a tendency to split into its ion. Only thing is that the tendency is very poor. Water, 2 water molecules I am taking. Suppose one is donating the proton, another one will accept it, and now this way we are having ions. Children's, H plus ion does not exist in the free state. It is not possible for H plus ion to exist in the free state in water. Henceforth, we represent it in this form H3O plus, also known as the hydronium ion. This is just a symbolic representation. In reality, one H plus ion will be surrounded by several water molecules. So to represent that situation, we have made this symbol H3O plus, which is just representing H plus ion surrounded by the water molecules. This is the splitting, and again the reaction goes back, means hydroxide ion will take H plus ion back, and again we are having 2 molecules of the water. So this is the ionization, and we can now write, children, at the stage of equilibrium, H3O plus hydroxide ion divided by concentration of the water molecule, But since the degree of dissociation is very small, so we consider this value to be constant. And since this value is constant, we replace this constant by another constant. It's very simple to understand. Out of 1 crore, if 1 rupee has gone, almost nothing has gone. So we use the word constant. Likewise, we are writing here concentration of the water molecules remains constant, and I am replacing it by another constant. So now it becomes a constant K into K dash, Again these constants we will replace by another constant, because two constants if you multiply you will always get a constant. Henceforth I am writing, replacing them by another constant Kw. Now here I am getting Kw equals to H3O plus hydroxide ion minus. Children, this is known as the ionic product of water. As I told you, at room temperature, 10 to the power minus 7 molecules will split. It means that if one water molecule is splitting, it is going to form one H plus ion. If 10 to the power minus 7 are splitting, they will form 10 to the power minus 7 ions. So now I will replace those values over here. 1 into 10 to the power minus 7 and 1 into 10 to the power minus 7. Kw is going to be 10 to the power minus 14. 1 into 10 to the power minus 14. This is the numerical value. Kw is now 1 into 10 to the power minus 14. Here we write at room temperature that is 273 plus 25, 298 Kelvin, hydrogen ion concentration equals to hydroxide ion concentration equals to 10 to the power minus 7. And thereafter we can express. So if they are asking you to obtain a derivation for the auto ionization of water, we can write like this. And this was the concept of the auto ionization of water. Now children, we will study we have just seen that Kw is going to be H plus ion ka concentration into hydroxide ion ka concentration. Whether you write H plus ion or you write H3O plus, they are one and the same thing. So, at room temperature, that is at 298 Kelvin, Kw is going to be 10 to the power minus 14. This is what we have seen, children. Also, you have seen that hydrogen ion concentration is going to be 10 to the power minus 7. Hydroxide ion concentration is going to be 10 to the power minus 7. Actually, this language of 10 to the power was not easily understandable by the people which are not from the science field, which are not from the field of chemistry. Hence, this complicated thing was expressed in a simplified way, so that even the people of other fields can understand. Henceforth, hydrogen ion concentration we can express as by taking negative log to the base 10, negative log to the base 10, 10 to the power minus 7. This entire was expressed as pH. Now minus and minus, now it will become plus 7. Log 10 to the base 10 will become 1. pH is what? 7. Minus 7 will come to this side. Minus is already there. Minus and minus will make it plus. So we are writing directly 7. 10 by 10 becomes 1. I will add one more step here so that it should be clear for you. Minus 7 log 10 to the base 10, which becomes 7 log 10 to the base 10. But by rule, log m the power n is always n log m. It is this formula I am using. Log 10 the power something I am taking to here. It becomes n log m, n log m. Also you have studied log m to the base m is 1. So log m to the base m becomes what? 1. Now children, pH value is now 7. Similarly, I can obtain hydroxide ion by writing 10 to the power minus 7, taking log on both the sides. It will become log hydroxide ion concentration, log 10 to the power minus 7. Take negative side on both the sides, minus log 10 to the power minus 7, minus log and take the base to the 10. This will be POH. This value will be minus 7 log 10 to the base 10. POH is going to be 7. Now children, on the same line, KW also can be written as PKW, and this value is what? 14. How? Let us see. KW is 10 to the power minus 14. Negative log to the base 10 of KW is going to be negative log to the base 10 of 10 to the power minus 14. This is now going to become PKW. This is minus of 14 into log 10 to the base 10. PKW is going to be 14. Now children, by knowing all these three facts, if we say that KW equals to hydrogen ion concentration and hydroxide ion concentration, I can also say that PKW equals to pH plus POH. How? Let us see. Taking log. If I am taking log, it will be log KW, log of hydrogen ion plus log of hydroxide ion, because you know the formula that log m dot n is what? Log n plus log n. All you have already studied in the 11th standard. These are the simple formulas. Log m into n is what? Log m plus n. So into value I am writing as log H plus log hydroxide. Taking minus sign, it will become log KW equals to minus log hydrogen ion plus minus log hydroxide ion and to the base 10 you take all the time. This becomes PKW, which becomes pH plus POH. Children's PKW value is what? 14. So pH plus POH comes out as 14. Now, on this basis, one scale was developed. And what is that scale? A Russian scientist, Mr. Soren Sen, in 1909, Soren Sen has made a scale for neutral water. Hydrogen ion concentration and hydroxide ion concentrations were same. That is 10 the power minus 7. In pH language it becomes 7. We have already seen in pH language it becomes 7. Either you say hydrogen ion concentration is this much or you say pH is this much. It is same thing. When the concentration increases means hydrogen ion concentration value, if suppose higher, means 10 the power minus 6. Remember, 10 the power minus 7 is a smaller number and 10 the power minus 6 is a greater number because of the minus sign. So the pH will now become 6. This side I am getting 6, 5, 4, 3, 2, 1. So as the hydrogen ion concentration is increasing, solution become acidic. And when the hydroxide ion concentration is increasing, solution becomes basic. Since the scale is only pH, so we talk in terms of hydrogen ion and hydroxide ion concentration. Children, we have to know that pH and POH has to become 14. Hydrogen ion concentration is increasing, we write like this. Decreasing concentration, I will write 10 the power minus 8. It is lower value. If hydrogen ions are less, means hydroxide ions are more. If hydrogen ion concentration is 9, I will write this way. Hydrogen ion 10 the power minus 7, 10 the power minus 8, 10 the power minus 9. Hydroxide ion concentration will become 10 the power minus 7 and 10 the power minus 6, 10 the power minus 5. Remember, when we say that hydrogen ion concentration is decreasing, indirectly you are telling that hydroxide ion concentration is increasing. And if the hydroxide ion concentration is increasing, solution will become basic. So here we write 8, 9, 10, 11, 12, 13, 14. This becomes basic. More you move to this side, solution will become more and more basic. More we move to this side, solution will become more and more acidic. So for common people, it has become very useful, very handy to find out the pH value to decide the acidity or basicity. Several soaps are there. Their pH values are already described. Even our blood, it is having a specific pH value. And even a minute change in that pH will cause death. Soil will remain fertile or not. That depends on its pH values. So children, all several discussions will now be, all several things are depending on this pH scale. So children, for the day we have we are stopping the lecture here, and let's see you in next lecture. By that time, keep on studying. All the best.